Okay, let me start my presentation. Okay. Hi everyone, I'm Chao from Worcester Polytechnic Institute in Massachusetts. My study is the effect of carbon dioxide and bio-effluents on driving performance. Dr. Skinny and Professor Xu Chao are co-authors, and they helped me to finish this study. Carbon dioxide has been used as an indicator of indoor air quality for a long time. Previous study usually invested its effect on occupant work productivity and learning performance. They indicated the CO2 has significant effects on the impairment of cognitive function, especially when it is more than 5,000 ppm in the indoor environment. The bio-effluent is a chemical substance that can be emitted by the human being. Previous study usually focused on its effect on the perceived air quality, and a few of them study its effect on the cognitive function. Driving is a daily activity needs the mental workload, and in the window closed vehicle can be. The CO2 concentration are typically less than 2,000 ppm, but it can be as high as 4,500 ppm in the fully loaded condition. Besides, the people in the vehicle also add the bio-effluents in the fuel space. Every year, there are 6 million car accidents happen in the United States, and 3 million people die in the car accident. The CO2 and the bio-effluents in the vehicle have the potential impairment on drivers' cognitive functions and driving performance. So it can result in the car accident. So we need to have a comprehensive indication of the CO2 and the bio-effluents on driving performance. In this study, we will investigate how the CO2 and the bio-effluents affect driving performance, and if they affect the cognitive performance during driving. We have 25 participants in this study. They are selected by the surface thickness screen test, and we use 3 different CO2 levels in our study: 800, 1800, and 3500 ppm. The driving task should be with one of the CO2 concentration. Another environmental factor is the bio-effluent. One driving task should have or not have the bio-effluent as a factor. And the bio-effluent is emitted by the T-shirt with the here. And in the chamber, we keep the temperature and relative humidity in the steady state and send to all the driving tasks. And we set the action rate is 18 per hour. It is then for the recirculation mode of the vehicle HVAC. The figure here is for the freeway driving for the all driving tasks. All the participants have 4 ways driving. The first is for training and the screen test. Another 3 ways for 3 normal driving tests. We assigned the different driving conditions to the subject randomly to address the order effect. Each driving visit is about 1.5 hours, includes wearing a sensor, taking a survey, and 2 driving tasks. Every driving task is about 80 minutes. 80 minutes is a critical commuting driving time. For the second task, we use unback. It is one of the most common cognition tasks that impose and measure the mental workload. And we use 3 different levels of unback tasks for 3 different difficult levels: 0 back, 1 back, and 2 back. And we use the unback to simulate using the phone or other entertainment device during driving. And we use the survey to measure the sleepiness, feeling to the environment, emotion, and the mental workload after driving. We also collect the driving data to investigate driving performance, like vehicle speed and elevation. We compare the driving data in different driving conditions, and we compare the data in different time windows, the 18 minutes and last 3 minutes driving. We use the average and reaction time as an index of the NBAC task performance, and we compare them in different driving conditions. The driving performance parameters can be classified as longitudinal control and lateral control. Speed is one of the longitudinal control. It is the driver's ability to maintain the car on the car running way. So in the right figure of the 18 minutes driving, it shows the CO2 had no significant effect on the average and standard deviation of the speed between any two different conditions. In the last 3 minutes driving, in the environment without bio-effluents, we can find CO2 has significant effect on the speed average between the low and the high CO2 levels. In the environment with bio-effluents, the CO2 has significant effect on speed standard deviation between the low and medium CO2 levels. The reason that a significant difference happened in the last 3 minutes is CO2 need more effects to affect driving performance. For the effect of bio-effluents, there is no significant effect of the bio-effluents on the speed performance. The linear equation is the index of the lateral control. Lateral control is a driver drive on the road in terms of lateral rate. So in this study, the right figure shows in the last 3 minutes driving, the deviation and standard deviation of the lane deviation varies a lot if we compare to the 80 minutes driving. For the effect of CO2 and bio-effluents, we cannot find the significant difference between any two different conditions. The right table is the p-value of the NBAC river comparison between different driving environments. In the environment without bio-effluents, the CO2 has significant effect on the average between the low and the high CO2 levels, and same to the environment with bio-effluents. And when the CO2 in the medium level, the bio-effluent has significant on average. For the reaction time, in the environment without bio-effluents, between the low and medium and between the low and high CO2 levels, CO2 has significant effect on reaction time. And when the CO2 is in high level, we can say the bio-effluent has significant effect on reaction time. So in summary, not only the speed and deviation I showed just now, some other driving performance parameters also show CO2 and bio-effluent has little effect on driving performance. And compared to the driving performance, the CO2 and the bio-effluent have more effect on the cognition task. So in the future, we will investigate the biosignal to say if CO2 and the bio-effluent have significant effect during driving. We will use the EEG or FMER. We can show the difference of brain signal in different driving conditions. Thank you.
Thank you very much.
Yeah.
Let me just check the Q&A here. Please. Okay. Don't see any questions.
Yeah, there's one just on there.
Sorry. Perfect. Yeah, sorry. Do you want to?
Sure. From Benjamin Marshall, he asked, at the speeds the participants were traveling, how much distance did the change in reaction time cover?
Sorry, could it again? I didn't catch it.
Okay, so Benjamin Marshall asks, at the speeds the participants, oops, that just changed in front of me, sorry, I lost. At the speeds the participants were traveling, how much distance did the change in reaction time cover?
So all the our driving scenario is about 20 minutes driving. So I remember the distance is about, so the average speed is kept at 50 miles per hour. So maybe it's about 10 miles of the driving.
10 miles?
Yeah.
I think that was the only question, Mr. Chair.